Hi everyone, my name is Matthew Moscoso and I'll be covering the chemical milling process. Here's a brief overview of chemical milling. Chemical milling is used to reduce weight of components by removing material through the use of chemicals. It is mostly used in the aerospace industry to remove shallow layers of material from large aircraft components, missile skin panels, and extruded parts for airframes. Reducing the weight helps improve the overall efficiency of aircrafts. It is also used in the semiconductor industry to fabricate microelectronic devices. There are a few steps that are performed in the chemical milling process. On the right-hand side, there is a diagram of this process. The first step is to thoroughly clean and degrease the surface of the metal to ensure good adhesion of the masking material and maintain a constant rate of material removed. Secondly, the material needs to be masked with paints, tapes, plastic, or elastomers. Next, areas that do not require masking is peeled off. The scribe and peel technique is used to remove the masking material. Then exposed areas are machined chemically using etchants such as hydroxide, hydrochloric acid, nitric acid, and iron chloride. Etchants depend on the material being used. Stronger metals will require stronger etchants. Lastly, the parts are washed with water and the masking is removed. They are also inspected to make sure that they meet the requirements needed. Chemical etching and chemical milling are processes linked together and used interchangeably because they have similar processes and chemically removed parts. One of the differences is that chemical milling uses etchants and chemical etching has two types of etching, mechanical etching and a photoresist as part of their etchant. The main difference between them is that chemical milling focuses on dissolving materials to reduce weight, and chemical etching dissolves material to create incisions, lines, and designs. Chemical milling has many benefits, one of them being that the surface results in stress and burr-free. This makes them ready for subsequent bonding, stacking, and actuation. Secondly, this process is cost-effective. Since most of the tools and operations are of low cost, they can be mass-produced at a way higher volume. Lastly, this process is highly scalable and ensures quality in most of their parts. Although chemical milling has many great advantages, there are some disadvantages. Most of the challenges occur because maskings and solvents used have been detrimental to one's health and environment. Rubber polymers and pigments are used in the maskings, which reacts negatively with some chemicals used for the etchants and releases harmful fumes. Some of the solutions is using water-based and polyurethane urea-based maskings as they help meet health and environmental regulations. Also, a carbon adsorption system can be implemented to capture the emission of solvents and etchant vapors, and they can also be recycled. Lastly, here are my references for the project, and thank you for listening.